Okay, welcome to lesson 5 in chapter 2. This is multiplying and dividing rational expressions. So we're actually saving adding and subtracting for last. If you remember how to multiply and divide regular fractions, it's actually simpler because adding and subtracting fractions has to involve a common denominator, which can be tricky to come up with, especially when algebra is involved. So today we're just doing the multiplying and the dividing. Don't forget that when you're multiplying, you can cancel common factors within a fraction or across the multiplication between two fractions. And we saw an example of that yesterday. So we're going to take a look here. I'm multiplying or dividing depending on which sign is indicated in the question. And I have to remember to also state restrictions as I go along. So for this first one here, there's a couple of different strategies for me to take here. I could just multiply straight across the top. And I'm changing it so that it's in alphabetical order. I had an a times an a cubed, so that's actually 4 a's being multiplied together. And then multiplying straight across the bottom, because that's how I multiply two fractions. I multiply the coefficients first, 3 times 5, and then there's an a and a b squared. And then I could also, from here, now I could start to reduce to lowest terms or cancel common factors on the top and on the bottom. So I notice that I've got a 15 over a 15, that's equal to 1. And I've got a b squared over a b squared, that's also equal to 1. And then I'm just left with a to the power 4 divided by 1a, and I'm left with a cubed. Times 1, but just a cubed. Now the other way that you could have done that question, so instead of starting that way, I could have done this question by first looking for common factors that I could cancel top to bottom or across the multiplication sign. So in the first fraction, I noticed that there's an a on the top and an a on the bottom, so they cancel to equal 1. And then looking across my fractions, I notice that I've got a b squared on the top and a b squared on the bottom. I can cancel them because of the multiplication in between. If it was any other sign in between those two fractions, I would not be able to cancel. And then similarly, when I look at the 15 over the 5, again, I'm looking across the two fractions. 15 over 5 is the same as 3 over 1. So the 15 cancels to a 3. And now I can multiply, I also see a 3 now on top of another 3. So I can cancel that 3 and the 3 on the bottom, and I'm left with just a 1. So I've actually canceled everything here except for the a cubed. So it was a whole lot of canceling to get me to a cubed. So my two strategies then are to multiply and then cancel, that's what I did the first time, or to cancel and then multiply what's left over. In both of these cases, I need to consider the restrictions as they were in the first denominators. So my very first denominator was 3 times a. So of course a cannot equal 0, or that first denominator would equal 0. And in the second denominator, 5 times b squared, so 5 times b, b cannot equal 0. So I have two restrictions. You can write it like that, or you can write a comma b does not equal 0. In our next example, again, I have two fractions and I'm dividing these two fractions. Don't forget that to divide two fractions, we flip the second fraction. Or take the reciprocal of it. And we change to multiplication. Again, I have a few choices for the order that I want to do things here, but I'm going to start with that. So I'm going to leave the first fraction the same. And then I'm going to change it to multiplication and flip the second fraction over. Now again, I have a few different options for what I want to do first, but I like to cancel first and then multiply because I don't want to get these huge numbers. First, I'm looking at the coefficients, and I notice that 26 over 13, that's the same as 2 over 1. And then looking at the other coefficients across the multiplication sign, I can cancel common factors. So 25 over 5, that's the same as 5 over 1. And then I'm going to take a look at each of the variables. I can look inside each fraction, or I can go across the two fractions. So I'm going to look inside each fraction here, and I notice that I've got 1x being divided out. So this 3 is going to change to a 2. Now I've got an x squared. And then y to the power 4 over y squared. Again, I'm dividing out 2 of those y's from the top. In the next fraction, I have an x that's going to cancel from the top, and 1x will cancel from the bottom. So I'm actually just left with x on the bottom. And then I've got 3 y's that cancel from the top, and when I cancel 3 from the bottom, oops, I'm left with 2. I'm left with 2. So I'm just going to clean this up because there's a lot of stuff has happened here. So I'm just going to rewrite what am I left with. You do not have to do it all like that in one step. You could take a few more steps if you like. So just cleaning up, this is what I'm left with. And again, I am multiplying in between these fractions. You might want to make your x's a little bit curlier so that you can tell which one's a times sign and which one's an x. And I can still continue to cancel before I multiply these together. So I can cancel, I've got an x on the bottom and 2 x's on the top. So I cancel 1x from each. And then I've got a y squared on the top and a y squared on the bottom that cancels. And I can do that because it's multiplication. And then I'm just multiplying the leftovers. So I've got 5 times x times 2, that's 10x. And in the denominator, I'm just left with a 1. So 10x over 1 is the same as 10x. Don't forget to state your restrictions. When I state my restrictions, there's actually 3 different denominators that I need to consider. So my first denominators came from the question. And then after I flipped and multiplied, I ended up with this third piece in the denominator. And I'm thinking about before I cancel, always when I'm thinking about coming up with restrictions. In each of these cases, though, it is just x times y times some other numbers, or maybe more x's and y's. So my restrictions are simply that x and y both cannot equal 0. All right, our next question is a little bit different because now my numerator has a subtraction in it, and my second numerator as well, or sorry, my second denominator has subtraction as well. It's multiplication in between the two fractions though, so I do know that I can cancel from the top to the bottom across the times sign. So I notice that I have 2 over 4, and these are both multiplications. It was 2 times x squared and 4 times x. So I can cancel that. 2 over 4 is the same as 1 over 2. And then I had x squared on top of x. So again, I can cancel 1x from the top and 1x from the bottom. And I'm just left with an x on the top. You can clean this up if you like. So now I've got x minus 2 over 2. And I'm multiplying. I'm just left with x on the top here over x minus 2. Now the x minus 2's are being multiplied by 1 on the top. So they are just multipliers times 1. I could think of it that way. Because the entire bracket matches the entire bracket on the bottom, I can cancel it top to bottom. So the numerator here is x times the bracket, the denominator is 2 times the bracket. I can cancel that out. And I'm just left with x over 2. You could also write that as 1/2 times x. Now when I consider my restrictions, I need to consider both of the original denominators. So the first denominator was 4 times x. That tells me that x cannot equal 0. And then the second denominator was x minus 2. So I need to make sure that that never equals 0. That means that x can never equal 2. In part D, we're looking at a division statement again. So again, I might want to start by flipping that over and changing it to multiplication. So I'm leaving the first fraction alone. I'm going to change it to multiplication and flip the second fraction. Don't forget, this gives me a third denominator to consider when I'm doing my restrictions. Because it's multiplication, everything is already factored, so I can start to cancel common factors that I see on the top and the bottom. Don't forget, with this addition fraction, I can just put brackets around the top and the bottom so that I can see that there is indeed an x plus 2 on the bottom and an x plus 2 on the top that cancel. And again, an x plus 1 on the top, and one x plus 1 will cancel. There's actually 2 of those brackets down there. And now I'm just left with, in the numerator, 1 times x, that's just x, and in the denominator, 1 times x plus 1, so that's just x plus 1. You don't need the brackets at that point, but you can keep them. And now I'm going to take a look at my denominators to come up with my restrictions. So I'm thinking about my first denominator, my second denominator, and then after the flip, that third denominator. So taking a look, I'm going to try to go in order here from smallest to biggest. Looking at that first denominator, x plus 2 cannot equal 0. That tells me that x cannot be negative 2. So that was coming from this first denominator here. And then taking a look at this third denominator, x plus 1 cannot equal 0. That tells me that x cannot be negative 1. And then finally, don't forget about this x by himself here. If that x by himself times the bracket, if that x was 0, 0 times the bracket would be 0, and I can't have that. So x also cannot equal 0. He's tricky to see. Watch out for him. Okay, our fifth example getting a bit harder. Don't forget that before I can cancel, things have to be written as multiplication statements. Here, just throwing brackets around the numerators and denominators doesn't help me find any factors that cancel. So instead, I actually need to factor the numerators and factor the denominators. So I'm going to do that with all 4 parts. So looking at the first numerator, I see that there's a common factor of x. So I take that out. And then looking at the denominator, I notice that it's a difference of squares. Remember, if your factoring skills aren't strong, you are going to struggle with the second half of this chapter. So go back to 2.3 and review. Looking at the second fraction in the numerator, I see a simple trinomial. So I'm looking for 2 numbers that multiply to negative 2 and add to positive 1. And I'm going to put x's at the front of the brackets and those 2 numbers at the back of those brackets. So it'll be positive 2 and negative 1. And then looking at the denominator, you might notice a couple of different things. Maybe you notice that that is a perfect square trinomial because I can square root the first term and get x. I can square root the last term and get 3. And 2 times x times 3 gives me 6x that's in the middle. So I know that I'm going to get the same bracket twice, and it's going to be the square root of the x squared is x, and the square root of the 9 is 3, and then taking that sign in front of the 6x, it's plus. If you don't like looking for that pattern, then you're just asking yourself what multiplies to 9 and adds up to 6, and you should get 3 and 3, and notice that those brackets are matching. Now that I've got it factored, I've got, it's all multiplication statements in the numerators and in the denominators. So I can start to cancel, and because it's multiplying between the 2 fractions, I can cancel top to bottom across that multiplication. So I see an x plus 2 on the top and on the bottom. I cancel it out. I see an x plus 3 on the top and 2 of them over here, so I'll take 1 away. And then I'm simply left with, on the top, x times x minus 1, and on the bottom, x minus 2 times x plus 3. It doesn't cancel that much, but it is much simpler than what we started with. Don't forget to state restrictions. So when I look for my restrictions here, instead of looking at the original denominators, I'm going to look at the factored form. It helps me out because now I can just ask myself what would make each of these brackets equal 0. So I can see at the last one there, x plus 3 times x plus 3. If x was negative 3, that would equal 0, and that would be bad. And then x plus 2 is the second last factor. If x was negative 2, that would equal 0. And then x minus 2, if x was equal to 2, that would equal 0. So any of those x values would give me an undefined statement. All right, our last one. Similar to part E, these statements are not factored, and I can't just simply throw brackets around them and start canceling things. So I am going to try to factor these. Again, you might want to go off into some rough work. So I'm just going to put my rough work over here in blue. And for my rough work, I'm going to factor. So I'm going to factor the numerator of fraction 1. So I'm just going to call that num1. And this is really just my own notation, just off to the side so that I can plug it back in. So I'm thinking about 9m squared plus 3m minus 2. I'm looking at that first numerator, and to factor that, I would have to have a product of negative 18 and a sum of positive 3. And so I go through the different numbers that would give me those, and I notice that 6 times negative 3 will give me negative 18, and 6 plus negative 3 will give me a sum of 3. So I can take that statement 9m squared and split the middle term, the 3m, into 6m minus 3m. And then my final term, negative 2, will stay the same as well. This has given me a factoring right by grouping situation. And I can take out a common factor. And take out a common factor. And I end up with 3m plus 2 and 3m minus 1. So now I can come back over to my question and put that in as my numerator. Then I would come off into my rough work and do denominator 1.
Just to let staff know, the internet is currently down and it is board-wide, just if you're trying to do things on your computer and can't.
And I can factor that it's a difference of squares. And then I can come back and put that factored expression back in. Now, when I write this next one, I am going to flip it at the same time. And what I notice in my denominator, so what was my denominator is now going to become my numerator. I'm flipping it over. So what was my numerator will now be my denominator. And factoring those, the yellow will factor as a perfect square trinomial. Whoops. So the square root of the first, adding sign, and then the square root of the last. And then the second denominator, that was the blue one, when you factor that one, you're going to get 2m plus 1 and 3m plus 2. So I trust that you can go off into your rough work and do that decomposition factoring. And now we're looking for factors that cancel top to bottom. So I see that I've got a 3m plus 2 and a 3m plus 2. It's all multiplication at this point, so that's how I know that I can cancel the brackets or the factors. And then I notice that there's a 2m plus 1 on the bottom over here, and I can take away one of the 2m plus 1s on the top. And then again, I've got a 2m plus 1 on the bottom and another 2m plus 1 on the top to cancel that with that one. And I'm just left with 3m minus 1 over 2m minus 1. So that's as simple as I can get. I still need to state my restrictions. So for restrictions, don't forget that I want to consider all of the denominators throughout. So both the yellow and the blue highlight were denominators at one point, and then also the denominators from the first fraction. So I need to think about each one of those brackets and making sure that it doesn't equal 0. Now I see that there are actually a lot of 2m plus 1s. There's one in each one of those denominators. So I need to make sure that it would not equal 0. I bring the 1 over and subtract it, and then I divide out the 2. So I know that if m was equal to negative a half, all of those 2m plus 1 brackets would turn into 0, and that would be bad. Looking at the first denominator, there's also a 2m minus 1. So that also can't equal 0. I bring the negative 1 over and I add it. Oops. And then I divide out the 2. So I see that m can also not equal positive a half. There's one more factor for me to consider. That's the 3m plus 2. So I know that 3m plus 2 cannot equal 0. Again, I bring over the 2 and I subtract it, and then I divide out the 3. Some of you will get faster at seeing those fractional restrictions. There is a bit of a pattern there, so if you can find that, it'll save you a bit of time. So then I'm going to summarize all of my restrictions together. And I'm going to put them in order from the smallest one to the biggest one. So negative 2/3 is the smallest, and then negative 1/2, and then positive 1/2. And that's it for today's lesson.